Hi, good morning, everyone. Welcome to Apache Con 2021. I'm really excited to be present here. Before I start, I would like to share one common limitation with most of the analytic platform in handling real-time and batch data. Most of the platforms are optimized for either real-time or batch, which means the approach, architecture, resources, components which are used for batch system are completely different from real-time versus and vice versa. In today's talk, we are going to see these challenges and we will see how Apache Druid bridge this gap. Before we start, I would like to explain about a challenge I have encountered in my journey as a data engineer. During this journey, I've used various framework for doing analytics, example, batch system like Apache Hive, Spark, Presto, Flink, whereas the platform like Apache Spark and Spark Streaming, Apache Kafka and Spark Streaming and the like have the capability to analyze the streaming data. This talk is about Apache Druid, how Apache Druid could query real-time as well as historical data in sub-second level of latency. A short introduction about myself. I'm Tijo Thomas, Senior Solution Architect at Imply. I started my big data journey from 2013-14 onwards. In this journey, I worked with Huawei, Hortonworks, Cloudera, and now at Imply. What we do. Imply was founded by original creator of Apache Druid. We provide managed service for Druid platform in cloud, Kubernetes, and even on-prem. We provide BI tools called a Pivot, optimized for Druid workload, and also provide a application monitoring tool for managing and monitoring Druid clusters. I will start this talk with a small use case of mine doing an analysis of sales campaign. And I'll try to solve my use case and help you to understand the gaps in analyzing the data with the existing other technologies, which I know. Here is the problem statement I have. I want to analyze my sales campaign and provide promotions. How do we do it? I'm getting my data in a streaming manner. So I want to show the number of unique users logged into my app in a dashboard on a real time and various reports on current campaign. I want to compare the result with my previous campaign as well. So let's take the common architecture. Back in the day, when we had not much option to store data, the only storage is database. The application store the data to database and basically the report or the BI tools connect to the database to generate the report. There is no concept of batch or stream. Whatever the data is available, it will be in DB and just go and query it from the DB. Let us review if this architecture fix my problem. Okay, I can query and get the number of unique users logged into my app, basically on a real-time basis. I can query various report on my current campaign and even the older one because everything is in database. I can compare the report with my previous campaign as all the data is in the same DB, but this approach is not a good practice as we don't want to overload the transaction database with all this kind of analytical queries. So how do we fix this? Okay, so this is a typical scenario that instead of querying directly from the DB, reports are generated from a data warehouse. But data warehouse does not have the real-time data because data warehouse get populated on a periodic manner. Example, data gets populated once in a day or so. So here I lost my data freshness. I need to wait for a day before I can query the latest data if the data warehouse is populated once in a day. Let's review this architecture if it satisfies my use case. I cannot query and get the number of unique users logged into my app because the data will be loaded to the data warehouse only after some time. I can query various reports on the current campaign and even the older one. The current campaign means I may not be able to query the latest one because the latest one will come next day. Again, I cannot compare the report with the previous campaign because the current data is not yet available as it's in the same DB. Yeah, so I have this limitation. So in addition to that, I want fast aggregation. Basically, mostly in my analysis, I want to slice and dice. Where the slice and dice queries are mostly group by in nature. So I need fast group bys. And I need data freshness as well. So let's see how we can use some other technologies. Like I use OLAP technique where the data is pre-calculated and kept. The goal is when we pre-calculate and keep the data or aggregate the data and keep, and then the analysis, the group by queries need to crunch less number of rows and it will be faster. So in OLAP, the data is being aggregated based on some dimension. And one of the common dimension is time dimension. Time dimension is a special dimension in OLAP. The reason is the event happens over a period and aggregation happens over a period. So I will explain that in detail in the next slide. On a regular interval, say once in a day, the data is read and pre-aggregated and stored in a different database. Since it is a pre-aggregated, my aggregate queries run faster. Now, group by queries, that is the aggregation, become lightweight. Now I can do slice and dice in my BI tool and my OLAP DB will hold it. How do we pre-aggregate? We will discuss in some of the common approach for the pre-aggregation. So here the input data is inserted into a table which holds the data for a smaller granular period, say for example 1 hour. Till 1 hour, all the data goes to this table. Every 1 hour, last 1 hour of data is aggregated and stored in a hour level table. The end of this day, the previous 24 hours of data from the hour level table is aggregated and stored into the next level of, that is the day level table. So here is the idea is there will be different tables for different granularity in time. Once the data is aggregated and pushed to the next level of table, it's optional to keep the data because the data is already aggregated and available. You can remove this data so that reduce the load on the system. When you query, the data is queried from a hour level table for the current day, and a day level table for the current week, and a week level table for the current month, and so on and so forth. So always you maximize the usage of aggregated data. So you don't need to crunch or run through all the data in all the rows in the data which is ingested because it's in aggregated format. However, this doesn't work out of the box. This requires some OLAP engine to convert the query to split into multiple queries based on the granularity and so forth. But it is possible. But you need to keep this data moving by aggregating from one table to another. This is a lot of work, right? I agree. A lot of maintenance effort. There are many places it can break, like if some reason the scheduler didn't run, data didn't move, it's escalation, a lot of challenges. Maybe we'll get the wrong data as well, because there is no alarms we'll not get. In this scenario, I'm using a relational database, and there is one more challenge there. Relational database is in a single node, so this architecture is not so scalable. As the data starts increasing, the storage of the raw data in the smallest granularity table becomes itself a big challenge. And the cost involved in storing those data, even for a short period of time, it's tremendous. So what's next? With the entry of big data, the entire paradigm changed. With the big data technology like Hadoop, MapReduce, and HDFS, huge data can be processed using more number of nodes. Here, the logic is to split the data into multiple smaller unit of work and process in individual nodes, and then collect the result back into the back and merge the result. So unlike the earlier approach where the data is processed in a single node, now the data is processed in a distributed manner. Now we can process huge volume of data with this approach. But all these approaches, in all these changes in the process of distributing the workload and merging the result back, has effectively increased the latency of the query to a greater extent. The query takes longer duration to complete, not because it doesn't have the processing power, but now it has to do more work. It has to split the query, distribute it after executing in each node, collect it, merge it. So this happens over the network, and there is a latency involved. In this transition, we lost the capability to process the data in real time, and compared to the first scenario, okay, where everything is in a DB. Yeah, so there are use cases we have to process the data in a real time. So in that scenario, the only option where earlier it was to query the transaction DB. So there is a alternate approach for doing that. Is whenever the data event occurred at the time before it insert into the database, the data can be replicated into a messaging queue, but the data can be processed on the real time like that. So again, it's not out of the box. You have to implement this. You have to implement it based on the business logic. When the data can be committed, at that time, you need to push it to a different storage. Different queue messaging service. Doing this reliably, again, is a lot of challenge. Maintenance is a challenge. A lot of exception handling, failure, etc. However, due to the need for streaming analytics, a new set of platform evolved. So Kafka, Spark Streaming, Flink, Storm, these platform can read from stream and process the streaming data some are in a micro batch. Some can have the capability to process one by one, and capable of handling the volume of data by scaling into multiple nodes. So even though there are small differences and similarity across these platforms, it does almost the same job. But this framework does not have the support to query both historical data as well as the streaming data. The only option is to fire the query to batch analytic platform and then streaming analytic platform. And someone has to come and do this merge and produce a final result. Often the application layer take this job of merging the result because that is the complex part, and it's difficult to implement a generic solution at the platform level. So this is a typical Lambda architecture. I don't need to explain about Lambda architecture, everyone knows that. Where the streaming use case is satisfied in the streaming path and batch use case is satisfied in the batch manner. The data from the Kafka is pushed to HDFS on a regular interval, example for once in a day. And whenever there is a query to the batch, the data will be fired to Spark. And whenever there is a need for a real-time analysis, the data will be handled by the Spark streaming. Let's come back and review if this satisfy my requirement. Can I query and get the number of unique users logged into my app? Yes, I can. Can I query various reports on my current campaign? Yes, but no. Yes, because I can query. No, because I cannot query immediately when this event happens. I need to wait till the data is made available to the batch system. I cannot compare the report with my previous campaign as the data is in the two different platforms. So some in streaming platform and old data is in batch platform. So either I have to do it by myself, that application has to do it, but the platform cannot do it. So there are some limitations. We'll review some of the approaches. Some business do, even though it is not very prominent. So one is Hive Stream and other one is Phoenix on top of HBase. Phoenix provides a SQL layer on top of HBase. So using Hive streaming, we can insert data into Hive in a streaming manner, but there are some limitations. Each streaming commit creates one file. Each micro batch, even if it is accumulating as a micro batch and committed, will also create a file, right? So this creates small segments, small files, and that is a big problem in Hadoop. Now, what are the limitations? So the limitation is data freshness. You know that the stream commits can happen only after a few minutes, and otherwise there will be a compaction pressure. Then the query latency. Hive is in general good for batch kind of workload, as overhead of the query is relatively higher. So even with the small data, the query completes with longer duration, like more than 5 seconds extra. Each query need to spin up a container, hence not good for use case which requires high concurrency. It doesn't work out of the box. Need to build a data pipeline to read the data from Kafka. Batch it in some other technology like Spark or NiFi, etc., and insert into Hive. This involves higher resource utilization and more components are involved in this. Okay, on. In 2020, ApacheCon, our CTO Gian Merlino has explained more about categorizing various big data processing and storage engines. In his talk, he's categorized HBase as a serving database, as a serving layer. I also like to stick on to that. I call HBase as a serving layer. By the way, if you didn't see that, it's a awesome talk. Never miss that talk. Yeah, coming back to the HBase. HBase is essentially a key value store with very low latency. Hence, we could pre-aggregate the data and keep it in HBase. The consuming app query this pre-aggregated data and display. Display in the sense pre-aggregate the data and provide it to the BI tool. The challenges: data freshness. Data need to be pre-aggregated in some other platform, and hence possible only after aggregating the data. Data can be pushed into HBase. Aggregation is slow, even though HBase it's basically a key value store and not a good candidate for a aggregation kind of queries. It is very efficient in kind of a pointed query, like select a column where table equal to key equal to ABC. That's a good candidate, but not a good candidate for a group by queries. Even the data is pre-aggregated based on the query. Further aggregation might be required on top of the pre-aggregated data. In those scenarios, this becomes really slow. We need to build a pipeline to read the data from the Kafka, pre-aggregate in Spark, insert into HBase. It involves multiple technologies. To be honest, pre-aggregation based on each use case is a lot of work. Not a suitable candidate for slice and dice kind of use case, and maintaining the pipeline and maintaining more platform and monitoring them, not only laborious, but require expertise in those technology. Even though this is not directly comes under total cost of ownership, indirectly contributes to the cost of maintaining the resource, maintaining the skill within the company. What if there is a single platform which is capable of ingesting data with best ingestion rate and can provide a single view on batch and real-time data with very low latency? Let's try this with Apache Druid. See this architecture. It's really simple. Druid has the capability to ingest the data from the streaming platform. So as soon as the data is ingested, which will take few milliseconds, the data is available for query. And this ensures the data freshness. Let's review if this architecture satisfies my use case. I can query and get the number of unique users logged into my app. Can I query the various reports on my current campaign? Yes. Data is readily available once it is ingested. I can compare the report with my previous campaign as the data is in the same Druid cluster. So Druid provides a single view of my real-time data and batch data. Okay, so I don't need to worry about which is real-time, what is batch. So what is Druid? Druid is Apache open source. It's a high-performance column-oriented distributed data store. High performance means low query latency and high ingestion rate. We are best in this category. Column oriented, best possible scan rate. Distributed meaning it can be scaled to hundreds and thousands of nodes. Data store, it's a clustered architecture. So a copy of the data can be stored locally and query from it. This is one of the reasons Druid is very fast. For those who are new to Druid, I'll take a minute to explain the Druid architecture and its component. It consists of query node, data node, and master node. Master node have a coordinator service which coordinates and manage all the historical data, all the data within Druid cluster. So overload service manages the real-time ingestion part of it. Now the query node accept the query and split into multiple subqueries and sent it to the data node. This is effectively done by a service called broker within the query node. Data node has two jobs. First one, the middle manager service in the data node need to respond to queries on real-time data and at the same time ingest the data. Historical service, it has only one job. It need to respond to the subqueries coming from the broker. Now, what broker will do, it collects the results from the historical as well as the middle manager and merge this to result back and send it to client. These are some of the typical use case where the data is also huge and need real-time analysis. But to be honest, this is not limited to any of this for verticals. How can I get help? Yeah, so there are Druid forums you can sign up, and there are community, Druid community, Apache Druid community. It's a really active community. Subscribe for the mail. There are Google groups, for Druid. Sign up for the meetup groups. There are SF channel for Druid. Please add, if you are already working in the Druid technology, please add your skill set and LinkedIn. Okay, so we have seen how this BI platform evolved, discuss about architecture based on the big data, seen some possible streaming architecture, how Apache Druid simplifies the analytic landscape, and we have seen the Druid architecture. Also, now how to reach out to the community. Thank you very much. Thank you very much for this great opportunity to share my thoughts on real-time and batch analytics using Apache Druid. Thanks for watching.